Hello and welcome you all once again to Maths by Gurpreet Sikho. If you haven't subscribed my channel till now, so don't forget to press the subscribe button this time before leaving my channel. So far, we have been discussing the chapter Linear Equations in Two Variables of 9th class NCERT book, and we have done successfully two exercises. Today we'll be discussing the topic of third exercise, and we'll be doing the examples related to third exercise in that video. So without wasting even a second, let's start with our work. As it's in front of you that we will be discussing graph of a linear equation in two variables. We have been discussing linear equations in two variables, and now we will learn how to draw the graph of a linear equation in two variables. We can do two things. Firstly, if the solution is given, for example x and y coordinates are given, we can know the linear equation, like what the linear equation is. It means we can construct a linear equation from the solution, or from a linear equation we can go to the solution. So there are examples involving both of the concepts, that how to solve a linear equation, which we have learned in the second exercise, and now we have to plot the points on the graph only. All right, so let's start with the very first example, that is example 5th. In this example, it's given that there is a point 1, 2. We are given with the point and we have to find the linear equation of this point. Like the first thing, solution is given but there is no linear equation, and they have also asked in the 5th example that how many such equations are there. So firstly we will try to construct the equation. Now just think a bit, and you would come to know that we have to write an equation in which if we fill 1 in place of x, we'll get the value of y as 2, or vice versa. Like if we fill the value of y as 2, we'll get the value of x is equals to 1. We have to find such equations. All right, so in your book there are 3 equations written, but you should not necessarily write all of the 3 equations, those 3 equations only. You can write any other equations from your own as well, but the thing is those equations must be satisfying these points. All right, so firstly let's write some of the equations. For example, the very first equation will be x plus y is equals to 3. How? Because you put x is equals to 1, you will get 1 plus y equal to 3, or y will be equal to 3 minus 1, that is 2, and 1 2 point is being satisfied by this equation. The next one will be y minus x is equals to 1. Now put x is equals to 1, you will get y is equals to 2, or put y is equals to 2, you will get x is equals to 1 in this equation. The next one will be y is equals to 2x. Put x is equals to 1, you will get y is equals to 2, or put y is equals to 2, you will get x is equals to 1. Right? These are the 3 equations that are already written in your book. But for your better understanding, let me write one more equation which is satisfying these 2 points. All right? That equation can be x plus y by 2 is equals to 2. When you put y is equals to 2, you will get 2 and 2 will be cancelled out, you will get x is equals to 1. All right, and when you put x is equals to 1, you will get y is equals to 2. So you can write as many equations as you can which are satisfying these 2 coordinates or this 1 point. All right, so what was our question, that how many such equations are there? So as it's very clear that we have written 4 equations, we can write 8, we can write 12, but it's only a matter of thinking and time. You can write, so there are infinitely many equations. This will be the answer of our question. Infinitely many, we cannot count, that is why they are infinite. We cannot count that how many equations are satisfying this point. All right, so there are infinitely many equations. So this was our example 5th. It was an easy one according to me. So let's move to example number 6th. This is our 6th example. Now we have to do the second one. We have to draw the graph of this equation x plus y equal to 7. We will learn step by step how to draw the graph of a given equation. Okay, so I have drawn a graph for your assistance, but you can draw on the graph notebook as well. All right, so x plus y is equals to 7. Firstly, what you have to do, just make a kind of table. It's not compulsory, but for your ease, make a table. In the first column you have to write x, and in the second column you have to write y. Now put x is equals to 0. The first point of every equation can be written by putting one variable is equal 0 and getting the value of other. So put x is equals to 0. Now write 0 in front of x. When x is 0, you will get y is equals to 7. So when we put x 0, y is 7. So our 1 point will be 0, 7, which we have to plot. Second one. Now put the second variable as 0 and find the value of the first one. Put y is equals to 0. You will get x is equals to 7. So what's the second point? That is 7, 0. Clear? This is how you have to find out the points, and then you have to plot. Now plotting is very easy, but while finding the points, it's a kind of complicated, because sometimes equations are complicated and most of the students get puzzled in adjusting signs, but it was an easy one. So put x is equal 0, you will get y is equals to 7. Put y is equals to 0 and you will get x is equals to 7. So these are the 2 points. We can draw graph very easily. Plot the point 0, 7. What is x? 0. But what is y? It's 7. So the point is 0, 7. What is x? That is 7. And what is y? That is 0. So the point is 7, 0. As you can see, connect both of the points and you will get a single line, and it was also an equation of line. Okay, so because it was a linear equations represent equation of line only, so that is why this is representing a line and we got a line. In this way we can draw a graph, and you can convert this into table as well, as I have told you. Like, you can draw the table or you can simply find the points. You can do as you wish. Clear? So we have drawn the graph of x plus y equal to 7 successfully. I hope that it was easy for you to draw the graph. Now let's move to the next example. In the next example, a statement is given and we have to form equation. Then we have to draw the graph. All right. In the seventh example, the statement is given as we know that force is directly proportional to the acceleration of the body. Now you must be studying science as well, so you know that force is directly proportional to the acceleration of the body. We have to write an equation and we have to draw the graph. Now for writing an equation, we need something that is equal to the other thing, but in this equation we are having something that is only proportional, and proportional does not mean that the thing is equal to the other thing. Proportional means if one thing is increasing, then the other one is also increasing, and if one is decreasing, the other one is also decreasing. This is what directly proportional means, and the opposite of this is inversely proportional. Okay, so if force increases, the acceleration is also increasing and vice versa. We have to represent it as an equation. Now we know force is F and acceleration is A. But in this chapter, we are studying in the terms of x and y only. So let force is equals to y units and acceleration, I am writing it in the short form, is equals to x units. Clear? Now force is directly proportional to the acceleration. According to given situation, according to given condition, y is directly proportional to x. This is the sign of directly proportional. Okay, now y is directly proportional to x, but we cannot draw the graph of this equation because we are not having equal to in between both of these terms. So it's a principle that when we remove the proportionality sign and inserts the equal to sign, we have to introduce a constant on the right hand side as well. So y will be equal to kx, where what is k? K is a constant of proportionality. We are just forming the equation, okay? We will be drawing the graph as well. Now, k is the proportionality constant, y was proportional to x, but when we removed proportionality sign, we added a constant, that is k. So now this is an equation, but the thing is, in a linear equation we also need some constants whose values are defined. For example, 2, 3, 4, 5. This is undefined constant, so let k is equals to any of the constant value. In your book they have taken k is equals to 3, so for your ease and comfortability I am also taking k as 3. Let k is equals 3. You can take k equals 2, k equals 4, 1 as well. We get what we get, y is equals to 3x. Now you have got a linear equation. Now you can draw the graph of this equation very easily because it's similar to example 6th now. Now what we did in the 6th example, we firstly found the values of x and y and then we plotted it in the graph. So let's do the same. As you can see, I have already drawn the graph and now we will be plotting the points. Firstly, let's draw the table. Again, x and y. We'll start with the value of 0 again. So put x is equals to 0. Simultaneously complete the table, alright, so that in order to avoid any of miscommunication and mistake. Put x is equals to 0, you will get y is equals to 0. And when you will put y is equals to 0, you will get x is equals to 0. So both of the points are same. Okay, so you don't have to plot both of the same points because they can't be plotted, and there is no sense in writing both of the same points. So now move to 1. Put x is equals to 1. You will get y is equals to 3. Clear? We have got the 2 points. In your book they have taken the point of 2 and 6, but we can take 1 and 3 as well, because why to probe directly on 2 when we have 1 in between? So when x is equals to 1, y is equals to 3, we have got 2 points. So let's plot. The first point, that is 0, 0, will be plotted on the origin only. It's automatically understood. Now when x is equals to 1, y will be 3. So 1 and 3 are coinciding here. This is the point 1, 3, and this is the origin, which is 0, 0, of course, and the second point is here. Now in the previous example we made both of the points meeting. Now in this example as well we have to connect both of the points, so we will be doing that again. Now as you can see, we have got a straight line, that is 1, 3 and 0, 0. I have written 0, 0 by forming an arrow that this point is 0, 0. So we have plotted the graph. Firstly, we made an equation. It was a complicated one, but I think you know that what force is directly proportional to. In this way you can make equation from any of this situation, and after that you can plot it. Plotting is very simple. Just take x0, then find the value of y. Just take y0, find the value of x. If both of the points are coming to be same, then take x equal to 1, find the value of y, take y equals 1 and find the value of x. You can find as many values as you can from this method. All right, in the next example there are graphs given and the equations given. So from the graph you just have to take the points and make them satisfying each and every equation, and in the equation in which the points are satisfying that equation will be relating to the same graph. Okay, so that example you can do very well because you have understood both of these examples, the previous examples as well, so you can do that very well. still, if you find any doubt in the eighth example and the sums of this exercise, you can drop your queries in the comment section without any hesitation, and I will be assisting you. All right, so with this we are done with our exercise, and I'll take a leave now. So before leaving my channel, don't forget to press the subscribe button, and it was great meeting you again. So keep practicing and best of luck with your practice.